Hello everyone, let me introduce myself. I am Facundo Carballo, and today I will create a ToDo List application, a decentralized application, using Solidity for the smart contracts, React and Next.js for the web application, and ChakraUI for the design of this web application. If you like to see more about ChakraUI, I have a video on my YouTube channel where I explain in depth what is ChakraUI. We will see how to create this Dapp, going step by step from scratch to the final web application, web decentralized application. I really try to explain everything, but if you had some questions, you can ask me on the comments your questions, and I promise that I will respond you. And I invite you to subscribe to my channel, because in this channel I will put some videos like this talking about blockchain development.
Before I start, like always, creating a React project. In this case I'm using Next and TypeScript for this project, but if you use a different framework or use JavaScript, it will work the same as mine. Obviously, we will have to install Truffle Suite, which bring us a lot of cool tools to work with smart contracts and the Ethereum blockchain. Inside of the folder of the React project, we will init our new Truffle project. This will create new folders and files that we will modify in the future. Now we will use Ganache, an app that runs a local Ethereum blockchain on our computer, and that will save a lot of time to us while we are creating our dApps. Once we have Truffle and Ganache installed and running on our computer, we have to configure our Truffle project. In the file truffle.config.js, we will find an entire file commented. Search the development section and uncomment that. Check in Ganache the port that is running on, and we modify the port in the Truffle config file. Finally, search the compiler section and uncomment all the settings. Change the optimizer to enable and comment the environment version. Now that we have all the config done, we can create some simple smart contract to check that Truffle is working, and we can talk with our smart contracts. All the contracts that we will create have to be inside of this folder called contracts. We create the most simple contract ever. Just have a simple public string variable that contains my name. Once we have our smart contract created, we open the migrations folder and we open the only file inside of this folder. In this file, we will have to add all the smart contract that we want to use, all called and executed in the same way. With the migrations file done, we can compile our smart contract using the command truffle compile. After that, we execute another command, truffle migrate -- reset, adding the smart contracts to the local Ethereum blockchain that Ganache provides us. Truffle, by default, will use the first account on Ganache. Therefore, this account will charge all the costs that deploy this contract generates. Finally, we can check if all of this works. To do that, we will use the Truffle console. It's a JavaScript console, and we create an instance of our smart contract like this. We can see how it stores all the content of our smart contract. Now we have access to all the public variables and functions of our smart contract. Therefore, we can store in a variable the content that returns the public function name. In that way, we can see how effectively we store Facundo, my name, that we have indicated in our smart contract. To create a decentralized application, we have to create some smart contract that talks to the blockchain. We have to think our smart contract like a database. From here, we will get all the data to show it on our frontend. Like we have to make a to-do list, it will be easier to use an struct that contains all the data that the task will have. Also, we create two events structs that will be used in the future. Since I want each wallet to have his own to-do list, I will have to implement a mapping function. The mapping functions are functions that always will receive some parameter that will be the key to search some unique value. In this case, we will have to pass some address to these mapping functions to get a unique integer. For example, if we pass the first address to this function, we will get the 70 number because that is the value associated with this address. In this case, we will declare a mapping function that receives an address and returns another mapping function that receives an integer and finally returns a task. In this case, we had some more complicated mapping function because it's a mapping function inside of a mapping function. So we have to pass an address as the first parameter to get another mapping function. So in this case, for example, we pass the first address and we get another mapping function with a lot of integers that represent a unique task. So if we pass the first address and also, for example, the 0, we will get the first task with the ID 0. But if we pass the first address but with the number 1, we will get the second task with the ID 1. After that, we create another mapping function that receives an address and will return an integer that will represent the number of tasks that this address deployed. Now we have to create all the functions that we will use in our to-do list. First, we create the function createTask, which will receive the content of the task. The ID of the task will be provided by the mapping function that we created before, taskCount, and the state of this task will always be false. Finally, we emit the event of createTask, and then we increase the value of the task count for this address, using the mapping function too. Now we have to create another function to use when the user completes the task. So we have to change the state of the variable completed. To do that, the function will receive an integer that will represent the ID of the task. With this ID, we can use the mapping function that we created before to get the correct task. These functions receive two parameters. First, the address of the user, and secondly, the ID that we receive as a parameter. After that, we can change the state of the task easily. Now we have to create a constructor that is a function that is called just once when the contract is deployed. And here we call the function create task, and we create some task for testing. Once we have our smart contract created, we have to compile and then deploy to the blockchain that Ganache provides us. Remember that everything goes well. We have to have the file of migrations, the instance of the smart contract, undeployed, like you can see. Later, in the terminal, inside of the folder of our project, we run the command truffle compile. After that, we have to migrate our contracts to the local blockchain. To do that, we have to run this command truffle migrate -- reset. And we can see how when we migrate our contracts, the first account of Ganache still spends some ETH. Lastly, we check that everything goes well, using the Truffle console. This step is optional. It's only to check that we can interact with our smart contracts. First, we get an instance of our smart contract using the name of the file where we write the contract, and then that deployed. Then we get an instance of our account to check that is the same address of the address that Ganache provides us. Later, we check the balance using the Web3 function getBalance, and we can see how the amount is the same that Ganache show us. And now we will get an instance of our task count using the function that we create on our smart contract. This function have to receive an address, so we pass our address, and we can see how this variable prints a big number, so we have to use the method ToNumber to convert this big number to a normal number. And finally, we will get an instance of some task. So we call the function task that we create in our smart contract, passing the account and an index that represent the ID of the task. So when we print our task, we will see an array where the first element is the ID, but in big number. The second element is the content of the task, that is a string. And then the third element is the completed variable, that it's also a big number because it's a Boolean variable but works like a number. So if we try to print the second element of the task, we will see how in the console prints the content of the task. In this case, it's hello world. Now we're gonna start with the UA. I had the idea of this UA on my head. It's a simple to-do list with an input where the user can put his new tasks to do, a button to finally add these new tasks to the list, and of course, a list that shows all the tasks that the user has to do. Also will be another list that shows all the tasks that the user has done. I will use a component library called ChakraUI that helps me to create beautiful UAs fastly. On my channel, I have a video where we see ChakraUI in depth. Once ChakraUI is installed, import all the components that we will use in our UA. Also, we import the next component called head that allows you to put some metadata in your HTML, like the title of the site, a description, or the favicon. Create a simple title which describes the project, and later we start to create the input where the user can add his tags. We will need to use some React hooks to handle the state of the variables that stores the data that the user put in this input. We continue with the button that will confirm the adding of this new task. We create the function to handle this button, but the implementation will be added later. Finally, we create a section where all the tasks to be done will go, and the section for all the tasks done. And this is the UI that we get. First of all, to interact with smart contracts using React, we have to use some React hooks like useEffect that allows us to execute some code each time that the website reloads. Inside of this hook, we will execute what we will make to get the data from our smart contract. The code that will be here, we will make it on another file to make it cleaner. In this case, I will create a folder called source, and inside of it, I will create a JavaScript file called functions. To interact with our smart contracts, we will need to install an extra package called Truffle contracts. Once we have installed it, we can start to make this file. I will start importing the JSON file that the migrate made us using the Truffle commands. This JSON file has all the data of our smart contract, but in JSON format. I will continue importing Web3. If you don't have Web3 installed, you can install it using this command npm install web3. Lastly, I will create an instance of the package Truffle contracts that we installed before. Now we can create some function that we will use in the useEffect hook. Inside of this function, it will execute different functions that we will create. The first function that will be in the load function will be load web3. In this function, we will use some code that Metamask provides us to connect Web3 with this wallet. The link to this code will be in the description. Of course, to do that, first you have to have Metamask installed. If you don't have installed it yet, it's easy, just go to the official website of Metamask and install it. Now we have to configure Metamask to use with Ganache. First of all, we have to see the test networks. So we go to configurations and then to advanced. And here we have to enable the show test networks. After that, we have to add our own test blockchain that Ganache provides us. To do that, we go to configurations and then to networks. Add a new network and you have to fill the form with this data. You can check if this data is correct in the app of Ganache, but normally this data is the same. Now, with the Metamask linked to Ganache, we can create the next function that we will use to get the current account that the user used to interact with the smart contract. First, I will check that all is going well. So I will print on the console the current account of the user. To get this data, we have to call the load function inside of the useEffect hook. So we import the load function and we call inside of the useEffect hook. We don't want to call the load function every time that the website reloads. So to handle that, we will create some state variables using another React hook called useState. So before we call the load function, we will ask if we want to get the data. If that isn't true, just return. But if that is true, first we have to set the refresh variable to false. And just there, we call the load function. Now, finally, we can try our load account function. Like we see, the console print a promise object. And that it's because I forget to add the await keyword before calling the Web3 function. Now, if we refresh the website, we can see now the current address. Now, like I want to work with Ganache accounts, we have to add these accounts to Metamask. In the Ganache app, we click on the key icon and copy the private key. After that, in MetaMask, we import an account and we paste our private key and finally import the account. I will do the same with another account of Ganache, just to use more than one account to test the smart contracts. Now, if we reload the website, we will see on the console the correct address of our current account. Finally, delete the console log and return the current account. So inside of the load function, we will have to receive it. Here I made a mistake that then I will resolve. I simply shouldn't put the curly braces to receive the account address because I don't return an object but a simple variable. We continue creating a function that gets an instance of the contract. Here we will need our instance of Truffle contract that we defined before. Start creating a variable that stores the value that returns the contract function. To this function, we will have to pass the JSON file as a parameter. We continue indicating the Web3 provider that we are using. After that, we create a variable that stores the content that the function deployed returns. Inside of this function, I want to get all the tasks that the user has. And like do this inside of this function, it will be a lot of code. I will create another function that returns all the tasks. This new function, called load tasks, will receive two parameters, the contract and the address of the current account. First, we get the amount of tasks that the user created using the function that we created in our smart contract, called task count. After that, we create an empty array, and then, using a for loop, we start to get the instance of each unique tasks of the user. We can get the entire task using our mapping function that we create on our smart contract 2, called tasks, and after that we push the task inside of the array that we created. Later we return the array of tasks. Now inside of the useEffect hook to the load function, we add the method then, where we will receive the object that the load functions return. And here we can interact with the data of our smart contract. We test our code and we will see that I have an error. Maybe you already figured it out, but I spent a good time trying to figure it out. I had called contract to the instance of our smart contract, but I also called contract to the instance of Truffle contract. So I have to modify one of them, but I have no better idea to name it with the same name as the variable that stores the value that the function of Truffle contract returns. After that, I compile the code and the app doesn't work yet. The problem was that I received the address like it was an object, but was a simple variable. Once I modified that, the app runs with success, and finally I can read the data of our smart contract and do whatever I want with this data. Now that we can read data from our smart contract, we can start to work with this data on the front end. I will store all the data that we get on the load function inside of the state variables using useState React hook. Now we can start to work with our user interface. I will print all the tasks to do and all the tasks done inside of each section. First of all, we ask if the task variable is still in null. If that is true, we will print a spinner to indicate that it's loading. And if it's not true, we will map all the tasks and print each row of task with the content and a button to toggle the state of the task. Like we are adding HTML elements in a dynamic way, we have to add the key element to the global component. When we get the task from our smart contract, we get an array where the first element is the ID of the task, the second element is the content of the task, and finally, the third element is the volume variable that indicates if the task is completed or not. Because of that, inside of the tasks component, I have to pass the second element of the array, which is the content of the task, and inside of the function of the button, I have to pass the ID of the task. So I will have to pass the third element of the array that we get. But adding the toNumber method, because like we declare it inside of our smart contract, an unsigned integer of 256 bits. This is a big number to JavaScript, so we have to convert to a simple number using this method. Now we create a function for the button, but I will implement it later. Here I realized that I should set the state variable as an empty array inside of the simple null. Now, finally, we add one more condition before printing the task. We ask if the volume variable of the task is uncompleted to show then the task to do of the user. Here I made a mistake in the condition, but I will fix later. Now we do the same for the task done, just we have to modify the condition to print the task. Now we try the UA, and here I realized that I made a mistake with the condition. It was backwards. Now I made some fix on the UA to make it prettier, and now we can start to implement the functions to add some new task and to toggle the state of the task. I will start with the createTask function. To handle that, I will use the instance of our contract. I will call the function that we create in our smart contract called createTask. This function needs to receive the content of the task to create it. We have stored the content of the task in the state variable input. After that, we set the state variable to an empty string. And finally, we enable to refresh. So when the use effect executes, it will get all the new data of our smart contract. Now we continue with the function that toggles the volume variable of the task. To do this, we also will need the instance of our contract to use the toggle completed function that we create in our smart contract. This function has to receive the ID of the task to toggle. After that, we enable the refresh to get this new data of our smart contract. Finally, we have to add some metadata to the functions of our smart contract. In both, we add the from metadata that indicates the account who wants to modify the state of the blockchain. Now, if we check our app, we will see how effectively, when we try to add some new task, a Metamask pop-up indicates that adding this task will cost some ETH. And the same if we hit the done button. Another thing very interesting for me is that if we change the account of Metamask and reload the page, all the tasks that we create with the previous account will disappear. Now, if we add some new task to this new account and later change the account again and reload the page, we will see how the previous task will return. So each account will have his own tasks, and that was the major requirement that I put myself.
So I hope that you really enjoyed the video and that you get the same result as me, and of course that you learn something about blockchain development.